Good evening, all of you. And here we have a very interesting problem from theory of equations, which is relevant and very useful in nowadays for JEE kind of examination. So AB belongs to real number, and A and B satisfy these two constraints. We need to find A plus B. Now, before you go further, you can give a pause and try by your own. Okay, so let's see the solutions. One natural way of thinking will be let's add these both equations. AQ plus BQ might give A plus B whole cube minus 3 into A plus B. A square plus B square will give A plus B whole square minus 2AB, then A plus B, 9 plus 11 is 20. And maybe we can something like do about it by manipulation. But the problem is here the equation is not quadratic. So if we substitute A from one equation, we'll try to put in the other, it is not going to be cool. So it will be extremely lengthy. So is there a smart way of doing this? Feel like the first expression, at least in terms of LHS, and the second expression looks very similar. So why not we can think as if we are talking about some general expression. Instead of personal noun, we are talking about x cube minus 6x square plus 13x, and which can pick up two values 9 and 11 depending upon at x equals a it will become 9, and at x equals b this expression is becoming 11. You see, instead of solving this directly, imagine if these two were equal. Okay, if these two are equal, directly I could tell like x cube minus 6x square plus 13x minus some hash equals 0, and it has got two roots a and b. So instead of looking at these two expression independently, we might see it together. Okay, so it's kind of these two are personal noun, and now we are trying to convert into a common noun. So we are combining these expressions into just a single packet. But here the coefficient 9 and 11 is unfortunately different. It's not same. What I'm talking is this. Imagine if I would have this problem, then how do you solve? So again, it's a similar problem. We have x cube minus 6x square plus 13x minus 8 equals 0. I can imagine I can capsule both equations just into a single packet. And now I know it will have root a and b. Right? So how many roots of these equations will be there? Clearly 3. So two values a and b definitely satisfy this. Other root we can either guess or maybe we can assume it's some alpha. Now first let's try to find other root. So clearly you can see if I'll put x equals to 1, which is basically factor of 8, we can give a try whenever you have quick equation for J problem. So 1 is definitely satisfying because 13 plus 1 14 and minus 8 minus 6. So alpha is already 1. And the question is finished because sum of root 1 plus a plus b is minus b by a, which is 6. So a plus b equals 5. Okay, so we know like this equation will have 3 roots. One root clearly I can see 1. Other root whatever it is, maybe a and b, real or complex. I know sum of root is definitely going to the 5. So how I have solved this equation? You see, just by observation, I have clubbed both information into a single packet. And those two individual chunks of information satisfies. The third I directly observed and sum of root we got. Of course, you have other method of solving this, because once you observe like 1 is the root of this expression, you can pull out x minus 1 as a factor. And remaining you can do x square plus something x plus something else, right, equal 0. This is giving 1 as the root. So now a and b must come out of this, right? Okay, of course we don't want a and b to be equal to 1 because 1 is already, so 1 distinct or not. So sum of root directly will get minus s minus b by a, and that will become nothing but 5 as answer. But there is a issue when we are trying to use the same logic for this problem, because no more now you can write x cube minus 6x square, because no more we can write x cube minus 6x square plus 13x equals something, because this something itself is changing. So how to deal about this issue? The best way to solve this problem is not to solve it, right? What we'll do instead, we'll solve some part of this, because I know this is problematic, so it's better not to even look at that problem. Okay, let's only concentrate on the LHS part. So at least no one can stop me to analyze f of x as x cube minus 6x square plus 13x. And we know at two values it will take 9 and 11 as the answer. So let's analyze this function a little bit. So you know it is x square minus 6x plus 13 Okay, so how this function will look like? In order to investigate the function, it's better if you can find the derivative. So 3x square minus 12x plus 13, and you can clearly see d is less than 0 for this, right? Because it's 12 square minus 4 into 3 into 13. So 12 common into 12 minus 13, which is minus 12. Okay, so d is less than 0. If d is less than 0, it means this function is strictly positive for all x, because this is a parabola. If d less than 0, it will have no real root, and since the coefficient of x square is positive, so always it will be upward parabola. So all for any x, the output you will get, the height that you will get is positive values. That helps us to solve like accurate graph. Here I'll draw accurate graph. Let's have a rough picture. So at 0 is 0, and it feels like it will be increasing like this. Now whether it will increase like this or this, so is concave up or concave down, that will be dictated by the second derivative. So it's better to get more feel of graph. Let's find second derivative. So 6x minus 12. First derivative will never die. It means slope is strictly positive, so the function is strictly increasing. But second derivative, you can see there is a turning point at x equals 2, because this guy dies at x equals 2. Basically, in the language of maths, we call x equals 2 is a point of inflection. So what is point of inflection? It's a point where concavity changes. So double derivative die at x equals 2, but single derivative at 2 is still positive. Okay. So since f double dash x is 0 at x equals 2, so at x equals 2 something is happening. Now what's happening? Let's analyze how this information can tell you whether you are like this or this. Okay, now you see, if x is more than 2, this will be positive. It means double derivative positive. Now what is the significance of double derivative is positive? It means final slope minus initial slope divided by change in x value is positive. Right? That is a definition of double derivative. Double derivative means f dash x dash. Now what is f dash x? It is df by dx. So it's basically slope, right? So this depends slope m, and m dash means change in slope. So change in slope. So f double dash x means dy by dx dash. So change in slope. So final slope minus initial slope by change in x is positive. We know change in x is always positive because you are always moving in any graph along positive x direction, increasing x direction, right? So f double dash positive means final slope is more than initial slope. So now you tell whether at x equals 2, if I move little bit up, so slope is increasing here. So final slope is more than initial slope. Like for this, slope is decreasing because you can see it's becoming more and more behaving like constant. So here if we have, let's say angle is 60 degree, here is becoming 40 degree only. So this cannot be the graph. So now I know definitely the actual graph of the function will be something like this. That makes sense? After 2. Now what will be the nature of graph before 2? Again you see x less than 2, f double dash x will be negative. It means final must be lesser than initial. It means it can't go like this. Why? Because before 2, if I take, let's say, any point, f double dash x must be negative. Negative means as you move ahead, the slope should decrease. So this will be wrong graph. So how the graph will be from 0 to 2? Roughly it will be something like this, because let's say at this point, if you are moving ahead, the slope is decreasing. Here you are making some 60 degree, here you are making maybe only 45 degree. Okay, so this is a theory. I am discussing theory as well, why double derivative, influence the concavity or convexity of graph. So now with this information, a very interesting answer we got. Equals to the height of the function is 10. So this comma is 2, 10. After this, the function will go like this. And before this, the function is decreasing. At 0 is 0. Right? So this is roughly the graph of the given expression f of x. Now it's very interesting to see that at 2, 0, the function has changes nature, concavity. So you see before 2, 0, function was concave down. After 2, 0, it's concave up. Hence we call this point of inflection. Those who already know all this, you can just play the video at 2x speed. Okay. The point was to deal with the basics. Now, what is the beauty of point of inflection? The beauty of point of inflection means, if you imagine if this were some node, okay, like some fixed hinge, you can basically rotate this curve and exactly will make them, like sleep on this branch. So this wing can exactly be rotated and it will exactly overlap this. So it's basically it is having rotational symmetry about this. What does it mean? It means from 2, if I let's say move x unit ahead, so I'll have some height, right, which is f of 2 plus x. If I move x unit back, so we'll have a point 2 minus x. I will have this height f of 2 minus x. So clearly, okay, the height that you are getting, so it's the function is symmetric about 2 comma 0, about point of inflection here in case of cubic. Okay, and that's a very important property of cubic over here. So this height, this extra height, which is f of 2 plus x minus f of 2, will be same as this height, right? So which is f of 2 minus f of 2 minus x, because of the symmetricity about this point. Okay, so basically I can tell this height plus this height by 2 is this. So this height is basically height at 2 is average of this from this equation. So f of 2 plus x plus f of 2 minus x equals 2 of. This clear? This you can prove otherwise also, because you see if this relation holds, then I can tell f dash 2 plus x, you find this derivative, minus f dash 2 minus x must be 0. If this holds, it means f double dash 2 plus x, right, and plus f double dash 2 minus x must be 0. And if it is true for all x, definitely it will be true at x equal to 0 as well. Right. So like if this is true, if f of 2 plus x plus f of 2 minus x is some constant, then from here I can conclude f double dash 2 is 0. Right. You can basically reverse the step and take a generalized cubic in fact if you want to prove, and you can see about point of inflection the cubic will be symmetric. Clear? So this condition is not only necessary, like even you can go back and prove this. What is basically 9 and 11? 9 is the function value at some alpha, right? So f of 2 plus x at this point, let's say alpha, we are getting some output as 11, because if this guy is 10, 11 must occur after 2 and 9 must occur before 2, right? So this guy is, let's add some beta, we'll have 9. Right? So f of alpha is 11, f of beta is 9, and what is f of alpha plus f of beta by 2? That is nothing but 10, and that's nothing but f of 2. So we already got f of alpha plus f of beta is 2f of 2, and that's really beautiful. If f of alpha plus f of beta is 2f of 2, if we'll compare, it means alpha and beta must be at the same distance from 2, right? So alpha minus 2 must be beta 2 minus beta. Hence alpha and beta must be at the same distance from 2. So alpha minus 2 must be 2 minus beta, which gives alpha plus beta equals 4. You can solve in other way also, as you have noticed, like x cube minus 6x squared plus 13x. If I'll just take that expression, that can be written as x cube minus 3x squared into 2. We can try completing cubes, right? Plus 3x into 2 square minus 2 cubes. So we have to add 8 and subtract it. So that gives you x minus 2 whole cube, right? Plus what is left over is x minus 2 and plus 10. Because you can clearly see till here we'll get a cube minus 3x square b plus 3b square minus b. So this is x minus 2 whole cube part. Now x plus 8 we can write x minus 2 plus 10. Why we are writing this? Because we want to write entire expression in terms of x minus 2. And this hint is coming by making perfect cube. Okay, so now our condition of problem is this expression was equals 9 in one case and it was equal to 11 in the other case, right? So a minus 2 whole cube, clear? Plus a minus 2 plus 10 equals 9. And b minus 2 whole cube plus b minus 2 plus 10 equals 11. And that's really exciting because you see the first equation can be written as equals minus 1. Right? And that's very exciting because this can be written as this equals minus 1 and 11 minus 10, this can be written as 1. So now basically we need to analyze just a function x cube plus x. This is 3x squared plus 1 which is positive, the function is strictly increasing as shown in this diagram. And now we know we have two inputs where we'll get minus 1 and 1. We can clearly say this function is symmetric over origin. Why? Because let's say at any value 5, whatever answer I'm getting, 5 cube plus 5, same answer we are getting in negative direction with minus 5, right? So this kind of function is known as odd function, which is symmetric or origin. So at x, whatever height I'm getting, at minus x is negative 1. So there is some input a minus 2 where I'm getting minus 1. So let's say this is some input a minus 2 where I'm getting minus 1. And at b minus 2 I'm getting plus 1. So exactly these distance must be same because of symmetricity of x cube plus x. So I'm getting plus 1. So this distance must be equal to this distance, right? So I can tell b minus 2 should be equal to 2 minus a. Because a minus 2 is distance, so since it's negative distance, okay, so to make it positive, we have to take minus a minus 2. Clear? So which gives a plus b plus 4. And you see this is also a simple way of doing this. But the thought process developed here seems a bit cosmetic, which might not strike you in the examination. Although the first solution was lengthy, okay, because the way I projected the solution, but it was more